Thank you. Thank you, Alan. Thank you, everybody, for coming. Thank you for hanging around for, again, our last talk in here. I'm going to move swiftly into the talk and drop too much of the introductions. But I do want to say first, thanks so much to the sponsors of DDD. It's been an absolutely incredible event so far as I've enjoyed it. And I also work for one of the sponsors. My name is Nash. I'm a developer relations engineer at DataStax. You're going to see a little bit about more what we do at DataStax, but briefly, we are building a generative AI platform for helping you to build those kind of applications. As I said, we'll see a bit of that. If you do want to catch me anywhere on the internet, I'm sort of Phil Nash all over the place. Pretty easy to find. Let's move on. How to work with generative AI in JavaScript. Now, I say JavaScript because that is my language of choice normally, and as Alan pointed out there, like Python is pretty much the popular decision for AI in general. But JavaScript, I think, is actually in a close second, and I think that we don't have to learn a whole new language if we want to play with it. And in fact, there's a lot of stuff we need to do in the front end and the actual user experience of this as well, and that's not all Python. But why now? Why generative AI? Like, this whole thing's really new and it's really exciting, right? The API for ChatGPT basically came out in March, April 2022. So we've had access to sort of generative AI as a developer for about a year and a half, 18 months, thereabouts. And so we're kind of learning this and learning as we go. And it's time to experiment, time to build with this kind of stuff. And I think that's really cool and exciting, especially because some of this stuff is it's almost unknowable what we can achieve with it. Right now, it's very exciting for people to talk with things like ChatGPT or Gemini or whatever, because they get interesting experiences just talking to a foundation model. But as developers, we have a lot more opportunity to work with this and do more interesting stuff. This whole thing is brand new. That's what I was going to say there. Yeah, cool. And the good news is that a lot of our existing skills are still applicable to all of this. We just need to know a couple of extra tools and how to work alongside those tools for now. And so, let's start with LLMs. That's impossible to read on that screen. Good stuff. We'll start with LLMs. There are APIs available for most of the large language models that we have out there. The biggest ones, hang around are Google Gemini, Anthropic and Claude, OpenAI, and the GPT series. There are others available. I just didn't have enough space on the slide. You don't have to host these things yourself. They are mostly available as API, and I definitely think that's the best way to kind of at least start working with them. For this talk, I'm going to use Gemini. I actually think it's really it's a fun API. It's a fun one of these to use. It works really well, and it turns out that it's quite cheap and useful. If you are trying to look at these AI APIs and models and wonder which ones are the best to use, this artificial analysis site is absolutely brilliant. And it's, I think it's actually built in Australia. It gives you kind of an independent analysis of different models and API providers. And this kind of top section is highlights showing from left to right quality, speed, and price. And so the quality ones kind of decide that OpenAI's O1 Preview or O1 Mini are probably the best right now. But then there's speed, which is also important, especially if you want some kind of user experience out of this. And the fastest, by far and away, is Gemini 1.5 Flash. Which is actually going to be the model I use for the rest of the talk. It also turns out it lays down there at the bottom of the cheapest section as well, which is not really a factor for me right now, but might be for you. O1 Preview, meanwhile, might be the best, but it's also far and away the most expensive. There's a lot more analysis on this page, so if you want to decide on a model without just trying them all, that's a good place to start. And so it's actually relatively straightforward to work with Gemini. That's really tiny, but don't worry about it, because it's not super important, because there's only like 7 lines of code there, and most of them are importing stuff. All of these things come with SDKs to use. Gemini's is nice and easy. You can go and download it. It's just called @Google/Generative.AI. I like that. It's actually fairly new news that the Gemini APIs now also support the OpenAI API, which is weird, but it means you can now use the OpenAI SDK to talk to Google Gemini, which helps you swap between them, I guess, but they also have their own library. Set it up with an API key, choose your model, and then ask it to generate content. Nice and easy. It's all asynchronous, it's modules. It's just using JavaScript the way we know how. And you can implement this into an application. So if I jump out of my thing there, I built a little chat bot. And this first version of it doesn't do anything except call straight to the model. And so if I say this was a chatbot for DDD Perth, for example, I could ask things like, what is Phil Nash speaking about? And it simply wouldn't know. And there we go, look at this. It's all like, oh, without more context, it's impossible to say. Also, thinks I know about C++, which is not true. That's a different Phil Nash. Lovely guy, not me. And so what we've done there is just build it's pretty cool that we can do that, but it's just not very useful. We've not achieved anything more than a consumer-grade kind of chatbot that doesn't know anything. And even like Gemini, when you use it as part of the app, Google allows it to go and search the web with Google. And so actually we've built a worse chatbot. That sucks. But we've got work to do. We can help this. And to do so, we actually kind of need to know a couple of things about how this actually works, what we're actually dealing with here. And so the first thing you will hear a bunch of times when talking about these models is tokens. Tokens are just what the models kind of turn to. Instead of using words, they kind of tokenize things. It's part of their kind of vocabulary. And the interesting thing about that is that like tokens can be a word, much like in this example from OpenAI. Like many words mapped to one token all are one token, but the word indivisible is actually made of 2 tokens. It's a brilliant demo showing that you have to divide indivisible in order to use it as a language model. And so some of these kind of bits are like the start or the end of other common bits of words. So isable will be a common-ish suffix to a bunch of words. And it's just how they understand things. It's also how they tend to charge for things as well. So you will be charged normally for input and output tokens when you're using these models. And then those tokens are really what we're generating. Every time we ask a language model like this to generate us an answer to something, what we're really asking it to do is kind of fancy autocomplete what we've prompted it with. And so if you pass a string once upon a time to a model, it's going to turn those into tokens, and then it's going to predict what the next token is. And any one time, it's only ever predicting the next token. And so if you give it this phrase once upon a time, it will probably predict that maybe the next thing is in. And then what you do then, actually this happens within the model, you pass the entire string back into it and predict the next token again. So we get once upon a time in once upon a time in our land. And every time we pass the entire string back through it and get one extra token out until it gets to some kind of ending state where it either believes it's answered the question or has run out of tokens that it's allowed to give you. It's important to note that for when we get to prompting in a bit. There are ways to change the behavior of this, because right now what it takes is it basically looks at the probability of all of the tokens that it knows about and says what the next most likely token is. And then it gets a bit random from there. It's actually allowed to pick relatively randomly from those next most likely tokens. And you can change that behavior with a few somewhat common parameters to the models. Top K allows you to just restrict it to the top set of K tokens that are the most likely ones. And so that kind of brings its randomness down because they are the most likely next ones to be there. Top P, meanwhile, is the top probability section. So you can say the top 10% most probable tokens we can pick from. And then the temperature actually just is how randomly it picks from that set of tokens. So if you turn the temperature right down to sort of 0, it basically picks the most likely token every time. And it makes it quite boring as such. Like it picks the most boring and most likely thing next to say. If you turn the temperature way up, temperature tends to go between either 0 and 1 or 0 and 2. If you turn it right up to 1 or 2, it will kind of be very scatter about its next tokens, and that can lead it off into madness. So like running the temperature at the absolute top, probably not a good idea. Ultimately, if you're looking for factual or more boring kinds of responses, if you want to, if you're doing an FAQ or a useful bot which kind of tells people about stuff, you want the temperature to be down. If you're trying to get it to tell stories and be creative, then you want that temperature to be up, so it's a bit more random and a bit more exciting with what it picks. But then beyond the model, we've got more work to do. Because that's kind of all that we do. We can ask it stuff, we can give it tokens, we can get tokens back from it, and we can decide how it's supposed to generate those tokens. But these models don't really know things, right? They've been trained on a lot of data, and then they make a probability about what the next token is that comes out when they try and generate stuff. They don't know stuff. But we can sort of tell them stuff. And this brings us to the idea of prompt engineering. I'm not the biggest fan of calling it engineering, because a lot of it is prompt fiddling about. But this is the common term for this. And the idea here is that we get to, the way we talk to the model encourages the way it's going to give us output. And so prompt engineering comes in a bunch of different ways. And so these examples are all prompts I put to Gemini 1.5 Flash and got answers from. Zero-shot prompting is as if you are just a regular user talking to a bot. Like, you're not trying to give it any examples, you're not trying to be anything special with it, you're just asking it questions or talking to it. And so you can give it instructions, tell me a story about a friendly goblin. Gemini 1.5 Flash invented Grobnar, not your typical goblin. Thanks. Which is kind of cool. Weirdly enough, like I've asked other Gemini models for stories, and if you ask for like a happy fairy story, it inevitably picks the female name Elira as the main character. Don't know why, but that's why I had to ask about goblins, so I got Grobnar. You can also ask questions of it, where's the capital of France, and that's sort of based on its knowledge, except, again, it's not knowledge, it's just that Paris was so likely to be the next token in that sentence that it had to be chosen. But this is zero-shot. That's not very useful when we're actually trying to engineer against this. And so a better way to get good examples and good responses out of a model is to give it a few examples, what they call one or few-shot prompting, where in this case, if you say, here's a country and a capital city, country and a capital city, eventually, and this was weird, I thought, from Gemini, I said USA, and it went, you got it. The answer is Washington, D.C. And it clearly believed it was a game show host at this point. And like, I appreciate that, but it's not the most useful thing. It's not exactly what I wanted out of it. Like, it did give me the right answer, but it didn't format it the way that I'd like it to. And so that's where we maybe look at the system prompt. The system prompt is made available by some of the models and gives you kind of a higher level of authority over user prompts to give it an option to, or not option, to take away options from it, to direct its behavior. And so if I tell it that it's a capital city assistant, and only to respond with the name of a capital city for the country or state that you're provided, and then give it some examples, it will simply just say Washington, D.C. to me. And that was nice of it. It stops trying to get me to play. So system prompt is useful to know that you can give it more overriding instructions than a user can. And then you get to interesting things like chain of thought processing. And this goes back to the fact that every time we generate a new token, we are passing all of the existing tokens back through the model. And if you ask a model to consider a chain of thought to break down how it would go about doing something and then do something, because in the middle of that, it's given itself a bunch of instructions on how to do something, the next set of tokens are actually more likely to be the thing it was supposed to do. It's actually kind of cool. And so in this particular example, I told Gemini it was a riddle-solving assistant. It will be told a riddle, and to break down its chain of thought and then come up with an answer, not to try and guess straight away. And then its prompt was, you see a boat filled with people. It has not sunk, but when you look again, you don't see a single person on the boat. Why? Does anybody know this? Gemini Flash did work it out. It said, here's my thought process for solving the riddle. The riddle focuses on the boat and the people. This suggests the relationship rise between the two. Yeah, sort of right. The boat is full of people, then empty. This implies a change in state or perspective. It's kind of starting to get there. And then the boat hasn't sunk, so this rules out any event that would physically remove the people. And then it answered, the most likely answer is that everyone on the boat is married, not a single person on the boat. Clever little bot. It got there, but it also kind of, like, it worked its way out there. So then we get to chat. And to chat with the model, that's kind of straightforward because what we are just chatting with it. But chat is nothing more complicated than sending the entire contents of the chat back to it each time. And so the longer a chat goes on, the more context you provide to the model so it knows what's going on. And so in this case, actually Google's SDK for this gives you the opportunity to start a chat. You can call model.startChat, and that will actually handle the state for you, which is nice. And so every time you chat.sendMessage, the SDK is going to send the rest of the chat to you. And so I have a little example of that. I'm just going to, oops, no, it's there. CO number 2. This is basic chat. So beforehand, the model didn't know anything, and I didn't tell it anything, and it wouldn't have remembered any chat. But this time I can say, hi, my name is Phil, and it's going to be like, oh, cool, thanks. When the internet is there. The internet. Something broke. Excellent. 503 service unavailable. Yes. So one of the interesting things about this all being new is that the internet has gone off. All right. No demos for you then. It would have remembered my name, which was nice of it. So next up, we have to think about context. So we've thought so far about like just talking with it and different ways of prompting it. But to give these models more context, we use a technique called retrieval augmented generation. And the idea behind retrieval augmented generation, or RAG, is that you store your data, private or up-to-date data, stuff the model couldn't have known, could not have seen before. The user then makes a query to the bot. We go and retrieve that relevant data from our database somehow, provide that data as the context to the model with the original query. The model then generates a response based on that context, and then ultimately, I guess, profit. We'll get to that point. We'll get to business models at some point. It's not in this talk, obviously. But the interesting part here is actually what retrieve relevant data kind of means. Because when we're chatting with a bot like this, we're not doing keyword search. We're not trying to talk to a search engine. We're talking to a bot. And so we need to retrieve relevant data. And the way that we go about that is via vector search. Vector search is very interesting. There are machine learning models out there that are capable of distilling text or other content into a multi-dimensional vector, basically a long list of numbers. And those list of numbers, because they are a vector in a multi-dimensional space, can be used to compare against other vectors and get similar things. And these vectors capture the meaning of the data. And so when you're searching via meaning and similarity to meaning, you actually get really interesting and relevant results. And vector search is interesting because it's hard to kind of think about multi-dimensional vector spaces. So we're just going to consider a two-dimensional vector space for a second. And if we had 3 results in it, you might think the most similar vectors to each other were the ones that were sort of physically closest to each other, but that's not true. Vectors aren't actually points in space. They are direction and they are magnitude. They are direction from the origin, from 0, 0 in this case, and sort of how far away from the origin they are. And so they actually act more like this. And when we're talking about meaning, and how that's been captured by the vectors, then vectors that point in the same direction mean the same things. It just happens to be that one of them just means it more strongly, maybe talks about it for longer, or with more emphasis on certain words. And so in this case, the 2 most similar vectors are indeed the one nearest the origin there, and the one at the far, the one pointing in the same direction. And we can work this out using trigonometry, which I'm really sad that I had to get back to trigonometry in life. But it turns out that databases mostly do this for us. My goodness. All right, I'm going to be a couple of minutes over. We turn it into content into vectors via machine learning APIs normally. There are embedding APIs available from Google, from OpenAI, from other embedding only providers, which is really interesting. They do some interesting work. But we also have we also tend to want to store these vectors in a database as well, because we don't want to have all of our data in memory and do trigonometry on it all the time. Vector databases have indexes that allow us to do that more efficiently. As I said, I work at DataStax, and we have AstraDB. That's our vector database. And it also has the nice function of it will, if you ask it nicely, to vectorize the data for you. So that's one less API you can think about. You then, if you have content to search against it, you can also use AstraDB to either, you can create your vector beforehand and use that to sort your data, or it will, again, vectorize things if you want to. I have to keep moving quickly because, as you can see, people are going. And we won't demo that because I guess we didn't have the internet either, so yeah, no, that's dead. Cool. Finally, the user experience of this kind of thing. Large language models tend to be slow. Even in the case where I like to use Gemini Flash, which is pretty fast, it's still slow to bring out paragraphs of text. And so as JavaScript developers, if we ever deal with the front end as well, we need to be able to make a user experience that's worthwhile for our users. And funnily enough, if you were in the last talk, that was Alice talking about like streaming in JavaScript. And streaming is actually really important for our user experience here in generative AI as well. If we are calling to these APIs that we can get data from, they tend to give us a streaming response, which is really useful. And so in this case, calling out to Gemini, you can ask for a send message stream, and that will give you chunks of data back, tokens, as they're created by the model. And so you can use, in this case, we've got for await const chunk of result stream. For await loops are really cool in JavaScript. Sadly, not available in all browsers, but if you're on the server side, you're fine. And then fetch itself, as an API, also does streaming for you. And instead of using the sort of promise-based response.text, response.json, we can actually just call on the response.body and pipe it through streams. And when you get a stream, you get a stream of bits. You get a binary stream, so you have to send it through. In the browser, we now have text decoder stream. Just pipe it straight through there, pipe it to a writable stream. And this example here will just keep appending to inner HTML. Not the best way of doing it, but fits on a slide. Oh yeah, there we go. But like response.body, pipe through decoder stream, pipe to writable. I think that's really nice. And so we can use that, and it's cool. I won't demo it because it ran out. There's a couple of extras just to consider. There are some libraries which help us with this as well. So Vercel's AI SDK gives us a unified interface to a bunch of AI providers, so you only have to learn one API, which is really cool. And it also simplifies streaming responses for frameworks like Next or Svelte or Nuxt, and even just helps out in Node as well. LangChain and Llama Index are initially Python libraries, but have been written to JavaScript as well. And they have they have similar kind of things, unified interfaces to the models, strategies for different versions of data ingestion, and useful patterns. It's actually really interesting to go read the documentation of these things and just see what other people have built with it, and give you ideas of how to go and work with it in the future. And the visual builders, we have a little visual builder at DataStax called Langflow that looks a little bit like this, but I won't spend any time on that. You can come and talk to me about it afterwards, though. But building as a GUI allows you to experiment and prototype with these things better. Function calling is something I absolutely wish I could get to in this talk, but function calling allows you to provide information to a model and then have it suggest functions it would like to call and the arguments it would like to call them with. This is super powerful for us as developers, and this really takes us beyond being just users and chatters with these bots, and allows us to make things happen in the real world. There are in-browser models so Chrome is currently experimenting with a small version of Gemini in Chrome itself. Very experimental right now, but possible that we may be able to make these calls offline inside a browser using the user's kind of device to actually do this inference, and that's kind of cool too. But that's all I've got time for. Now is the time to build with this kind of stuff. It's time to experiment with it and understand it. Look into how we prompt things and how we can call functions and how we can build up agents. Learn this now, and you will be, I think, in the right place for future development to come. The slides are behind that QR code if you're at all interested. And otherwise, thanks so much for coming, and enjoy the rest of DDD.
Thank you, Phil. Thank you, everyone. Unfortunately, we don't have time for questions, but I'm sure you can catch up with Phil.
I'll be around for the rest of the day.